Hey, BC Calculus, this is Mr. Canfield. All right, so I said I was going to go through everything here, so I'm going to go through everything here. I'm even going to do the ones that I said I wasn't going to do. So here we go. The very best. All right, so when we're taking basic integrals, the first main idea, is it focusing? Okay, yeah, first main idea is we take, if it's a polynomial kind of thing, we add one to the exponent, so it's gonna be x to the 7, so 7x to the 7, and divide by the new exponent of 7, so 7 over 7 cancels. And we're just left with x to the 7. So same thing on this next one, so we go up to the 4x to the 5th, divide by 5, which is why we get 4/5 x to the 5th. And then this is actually x to the 7/5. So then we add one. So 7/5 plus 5/5, 12. So we get x to the 12/5, and we're going to divide by 12/5. But remember, when you divide by a fraction, you multiply by the flip. So 5/12, x to the 12, 5. All right. And then with constants always come from just x. So that's going to be plus 3x. And then we always put the plus c for the constant of Instagrammation. Yeah, that's what I meant to say. The constant of integration. All right. Number 2, anytime we're dealing with an integral and it's plus and there's a single thing underneath, a possibility is that we're going to take this and break it apart. The reason this is good is these are both now algebraically very simple to deal with before we do any calculus. I can rewrite this first one as 7x to the negative 1/2. And in this one, this is 3x to the 3/2. This is x to the 1/2 down here. So you're doing 3/2 plus negative 1/2 or 3/2 minus 1/2. You're getting 3x to the 2/2, which is 1. So 3x to the 1. I haven't taken the integral yet. I've just done some algebra. Now when I integrate it, we get our 7x to the 1/2, because negative 1/2 plus 1 brings us up to 1/2. And then we divide by the 1/2, which is 2 over 1 times that. And same thing here, 3x, we add 1 to the exponent, 2/2. So 2 times 7 is 14, x to the 1/2 plus. So you can do 3x squared over 2 or 3/2 x squared. Those are identical. All right. On our next one, so I'm going to pretend for right now this just said cosine of x. If this just said cosine of x, then its antiderivative would be sine of x. Similarly, if it was secant tangent, well, we took the derivative of secant to get that. And this is just an x in there, so we can just leave that. And then cosecant squared comes from cotangent. But remember that the derivative of cotangent is negative cosecant. So to take care of that plus, we'll say minus cotangent. And this would be the answer. We'd be done. The only little trick here is it's not x in here, it's x over 5. If I took the derivative of this, we would get cosine x over 5, but then a 1/5 would pop out because of the chain rule. So to take care of that 1/5 that's going to pop out and then disappear, I can put a 5 here. So if I take the derivative of this, I get 5 cosine x over 5 times 1/5, and now the 5 and 1/5 cancel each other out. So feel free to reach out if you need more clarification on that. All right. I mean, we could just use u substitution. That'd be fine too. All right, number 4. I don't know what I was thinking with this. Oh, I do now. All right. Well, you get clarity on the second day. So we know cosine squared x plus sine squared x. We'll deal with this in a second. We know cosine squared x plus sine squared x is equal to 1. What happens if we divide and turn, can I turn any of these into tangent squared? And yeah, I can turn sine squared into tangent squared by doing cosine squared. Sine squared divided by cosine squared is tangent squared. So I'll just do that to all 3 of them. If I do that, I get 1 plus tangent squared is equal to secant squared, because 1 over cosine is secant. And this just has a plain tangent squared, so let me subtract the 1 from both sides. We can say that tangent squared is equal to secant squared x minus 1. So I'm going to rewrite these. 1 over cosecant, that's saying the flip of cosecant. Well, we know that cosecant is 1 over sine. So what happens if we flip that? It just goes back to regular. And instead of writing tangent squared here, I can write 1, nope. I can write secant squared minus 1. So now that we have this rewrite, well, check it out. What's the antiderivative of sine? Cosine. Oh, wait, no, it's not cosine. The derivative of cosine is negative sine, so I need to account for that. Secant squared. Oh, hey, we get secant squared when we take the derivative of tangent. And then this minus 1 turns into a minus x. So I did not see my own trick when I told you guys you didn't need to know how to do that. So whoops, but that's how we would do that. Okay, so that's all that's like possible to be on the quiz, but just for kind of brevity and making sure that if you want a 5, you need to know how to do all this stuff. So y equals f of x. If f double prime is equal to this, f prime of 0 is 3, and f of 0 is negative 1, find f of x. Okay, well, if we integrate both sides with respect to x of this, we'll get f prime. So the integral of x is x squared, and then over 2. Integral of 2 is 2x, and then constant of integration. So, but we know that f prime of 0 is 3. So this is f prime. So why don't I plug in 0 for x, and then we get 3. Hey, wait, 0 squared over 2, this is just c. Okay. So then I can say f prime of x is equal to x squared over 2 plus 2x plus 3. So if I want to find f of x, I'll just integrate again. And here I get f of x, and then here I get x cubed over 2 over 3, so that'll be over 6, plus 2x squared over 2, which is just x squared, and then plus 3x plus c. Oh, but we know f of 0 is negative 1. Oh, so I can just plug in 0 for x again. 0 cubed over 6 plus 0 squared plus 3 times 0 plus c is equal to negative 1. Hey, these all die, it's just c is negative 1. So final answer, let's say f of x is equal to x cubed over 6 plus x squared plus 3x minus 1. All right. A race car accelerates at a rate of 3 meters per second squared. So I could say a of t is equal to 3. 8 seconds after it starts accelerating, it is going that speed. or that velocity. How far has the vehicle traveled during the first 10 seconds of this acceleration? Okay. So we know that if I want velocity, well, velocity is just our integral of acceleration, because the derivative of velocity is acceleration. So velocity is just 3t plus c. So, oh, and we know 8 seconds after, so 3 times 8 plus our constant is equal to 39 meters per second. Let's see, 39 equals 24 plus c, subtract the 24, is that 15? Okay, so we know v of t is equal to 3t plus 15. How far has the vehicle traveled during the first 10 seconds of this acceleration? So we need position. But it doesn't tell us anything about like the conditions of the position. And the reason is, if we want to find out how much distance it covered, we just need to integrate velocity. And it says during the first 10 seconds. So we could just integrate the velocity from 0 to 10. And again, I said there aren't going to be any bounds to deal with on the quiz, just to kind of keep things straightforward. But so let's just, I'm just going to do this for the sake of doing it. It's a good problem to know how to do. So we're going from 0 to 10. So if we plug in 10, so 3 times 10 squared over 2 plus 15 times 10 minus 3 times 0 squared over 2 plus 15 times 0. All right, so minus all that. That's going to be 0. Sweet. So here, 300 over 2, what, 150? Plus another one. Oh, interesting. So 300. Oh, wait. This is a word problem. How far? 300 watts. Meters. Okay. First paper done. Second paper. Which one do you want me to do? Yell at your screen and tell me. That one? Cool, thanks. All right. So I'm going to be taking the bounds off of these. No bounds, I guess except for number 2. So this one, I'm like, oh, what tricks do I need to do? No, just do some algebra. So you get x cubed minus 6x squared plus x squared minus 6x. So we're just taking the integral of x cubed minus 5x squared minus 6x dx. So we'll just add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent, plus c. There we go, done. Only do u substitution when it's profitable. All right, number 2. I'll say what I mean later. Number 2, okay, find the, oh, that parenthesis should be here, I think, whatever. The derivative of this integral, shouldn't even, all right, anyway, oh, this is 3, if you haven't seen that commercial. If we're taking the derivative of an integral, everything stays the same except that bound gets dropped in. Had this been something different, like I think we'll see on the other paper, like if it was x squared or something, we would do chain rule and then do extra. I kind of flubbed my explanation of that in class. But anyway, we'll see it in here. Okay, number 3. Okay, I see the 22nd power. There is no way I am going to multiply this by itself 22 times. So I'm wondering then, I've got this and I've got this, and could I replace one of them with like a u to do u substitution? And the way you pick which one to do is think about the derivatives of these and think about, is that derivative something that is essentially present that I'll be able to like cancel stuff out with? So here I see this x squared. I know when I take the derivative of x squared and of x, I get regular x and a number, which is what we have here. The derivative of this is just a number, which isn't going to do a lot to change the way this looks. But if I can say u is equal to 4x squared plus 8x, then du is equal to 8x plus 8 dx. So dx is equal to du over 8x plus 8. Like that's really what's happening here. So what do I get when I replace? I get u to the 22. That's easy. Okay, so yes, this is probably what I want to do. And then 4x plus 4, well, okay, 4x plus 4 is still there. And then times du over 8x plus 8. Oh, wait, hey. 4x plus 4, 8x plus 8. We could think about that as 4 times x plus 1 over 8 times x plus 1. And cancel the x plus 1s. Oh, and then the 4 over 8 goes to 1/2. So we're really just looking at, I'm going to pull the 1/2 out front. 1/2 integral of u to the 22 du. So I'll just add 1 to the exponent, u to the 23, and then divide by 23. There's already a 2 down there. So final answer, I'll say my u was that. So u is equal to 4x squared plus 8x to the 23 over 46 plus c. All right, if you're like, hey, you forgot plus c on that one, I didn't. This is a derivative. All right, so number 4, I believe I said, don't worry about this one. I will do this. I'll do that at the end. I'm going to go through and do these 2 papers, and then I'll talk about methods for tackling those. 5 is a good one, so let's talk about that one. So 3x plus 4 is going to be our u value. You don't have to do a u subs on this. There is a way to do like kind of all mentally, but I can cover that later. Du is equal to 3 dx, so dx is equal to 1/3 du. So if we go in, oh yeah, no bounds. If we go in and do replacement, then we get 1/3 integral of u to the 1/2 du. So then it'll be u to the 3/2 times 2/3 with a 1/3 there. So that's 2/9. 3x plus 4 to the 3/2 plus c. So 6 will work essentially the same way. Your u value is going to be the inside there, and you go through and do stuff. I'm going to talk through how we would do that without writing all the u stuff on this. So the 2 just comes out. Like, we don't need to worry about that. And then if we think about this, well, the derivative of sine is cosine. So I know it's going to be 2 sine, and then that 8x is stuck. And the only thing that we have to do left is, well, if I took the derivative of this, I'd be multiplying by 8. And there is no 8 here. So I'm just going to divide by that 8. And so final answer here is going to be sine of 8x over 4 plus c is how I'd write that. That's another one that, that one at the bottom is another one that I can go over that at the end of the video. I just want to kind of get through the main stuff for people who want to just pass my quiz. All right. So if I saw this question, this is another one where it's a binomial over a monomial. So I can break this apart and say it's x to the 6th over x squared plus 1 over x squared dx. So clean that up, what, x to the 4th, and then plus x to the negative 2. So when we integrate it, we'll get x to the 6th. Nope, 4 plus 1 is 5. X to the 5 over 5 plus negative x to the negative 1 plus c. And you could rewrite that as 1 over x. All right. Number 2. Bye. All right. So you could do 1 over cosine minus sine squared x over cosine. And like, all right, I'll try to figure this out. I could rewrite that then. I could write it as secant x minus, well, sine over cosine is tangent. And then over cosine, G, I don't know any antiderivatives that are doing with any of that. Have I pretended enough? All right, now so now what we actually do to make this work. We know that sine squared plus cosine squared is equal to 1. So oh my goodness, I've been shaking my knee and probably shaking the camera. Sorry about that. So whatever method of substitution you want to use here in the numerator, you could subtract the sine squared from both sides and get cosine squared x is equal to 1 minus sine squared, which in that case means we have the integral of cosine squared x over cosine dx. Don't do any calculus yet. Hold on. What's cosine squared over cosine? Cosine. So then our antiderivative, that's just sine. That's irritating. All right. 3, this is a very, very good u substitution question. So we look at this and we're like, oh, I got a bunch of weird stuff going on. But the derivative of this is 3x squared, which is right there. So we can say u is equal to x cubed, du is equal to 3x squared dx. So dx is equal to du over 3x squared. When we do this one, this is like a direct u substitution. There's no funny business. I'm going to change that to the 1/2 power because it helps me. Remember when we're doing u substitution, all the x's should die. There should only be u's left. Well, we just add 1 to the exponent, u to the 3/2, divide by it. So in this case, it's 2, let's see, x cubed, okay. X cubed to the 3/2. Oh, no, it isn't. X cubed plus 7. I'm sorry. But the 7's inconsequential because it's a constant. I'm glad I caught that. Sorry about that. Plus 7 was supposed to be there. The derivative made it go away, so I forgot about it. And it doesn't change any of our work, it just changes our final answer here. Over 3 plus C. Okay, cool. Let's keep going. Number 4. So 4, this is another one where, so you might think we can break it apart, but this is where it's multiple things added up in the numerator. When it's a gross denominator, there's nothing you can do. You're stuck with a gross denominator. So hopefully the derivative of this has to do with x squared, and it does. So that tells us to do 8x cubed plus 4 as u. So then du is 24x dx, 24x squared, sorry. 24x squared dx, and then, so du over 24x squared. So let's see what happens. If I do that, I get u to the 12th, 6x squared is still there, and then du over 24x squared shows up. Hey, x squareds kill each other. 6 over 24 is a quarter, so we can pull the quarter out front. Integral of u to the negative 12th du. It's 1 over u, so rewrite it. Hey, sweet. So we'll add 1 to the exponent, u to the negative 11, and divide by it. So 1 over 4 divided by negative 11, negative 44. Okay. So final answer, I'm going to do negative 1 over 44 u to the 11th plus c, and my u was 8x cubed plus 4. Boy, howdy, was that fun. All right. So, yeah, that's it. That's what I would expect on the quiz. Hey, just under a half an hour, like I said. So I am now going to do all the questions that I skipped. So I skipped, oh, is that the first one I skipped? Okay. Oh no, I technically skipped this one. Average value, there's average rate of change, then there's average value. Average value is 1 over b minus a integral from a to b of f of x dx. So what I would be doing here is I would be integrating this and then plugging in my bounds and then doing over 3 minus 1, over 2. All right, number 5. So the reason number 5 is weird is because this and this doesn't really like, what? It's not really doing anything. But if I set u equal to x minus 4, then du is equal to dx. Well, that doesn't really help. So if you're, I got my x plus 1, I got my u to the 1/3 du. There's still this x stuff here. And so what we do here is hopefully my pause was enough. What we do here is we use this u here, and let's solve it for x. If we add 4 to both sides, we get x is equal to u plus 4. So what I can do here is instead of writing x plus 1, I can write u plus 4 plus 1. And if you're like, why would I ever do that? Because u to the 5th times u to the 1/3, algebraically speaking, is much simpler to handle than this. Because now I can say this is, well, This is 1 plus 1/3, so this is u to the 4/3. And this is 5u to the 1/3. And now if I integrate that, I get u to the, add 3 over 3, what, 7/3? So times 3/7. And then what, 4/3, 5u to the 4/3 times 3/4, so 15/4 plus c. So now we actually have an answer. So 3u, my u's look like n's after a while, don't they? I used x minus 4. Okay, so 3 times x minus 4 to the 7/3 over 7 plus 15 times x minus 4 to the 4/3 over 4 plus c. So it's messy algebra. This is called double U substitution. It's an advanced tactic, but there it is. All right, number 6. Which one's easier, 6 or? Oh wait, yeah, I skipped stuff on the other paper too. They're really similar. Okay, so for this one, excuse me. So the thing is, if I'm looking at the area under this curve from 0 to 6, remember that absolute values are like this kind of thing. They're like a bouncy thing, and they're always positive. So like, well, they're always non-zero, sorry. So I'm gonna need to figure out how this works. It's actually just a piecewise function. Absolute value of 3x minus 5 is a piecewise function. Sometimes it's just the normal function. Sometimes it's the exact opposite. So when is it the normal function? Well, it's the normal function when we get 0 or anything positive. Well, that happens at 5/3 because that's the 0 for this. And then anything greater, minus 5 will be positive. So greater than or equal to. And so therefore, when x is less than 5/3, that's going to give us that's going to give us the opposite. And so what we can do now is we break this integral apart. We say, hey, from 0 up until 5/3, we've got, well, that's less than, right? So we've got this negative 3x minus 5. Or you could also say negative 3x plus 5 if that's more your speed. And then you can say from 5/3 on, 5/3 until you hit 6, it's 3x minus 5 dx. So I'm not gonna do the work after this, because now you just integrate it, you do the bounds, you do all the stuff. But this is it's a thing we could see on the AP exam. So let me just bring this over to talk about this one from the previous page. This is very similar, right? It's going to be, sometimes we have the 2x minus 1, and sometimes we have the negative 2x plus 1, or the negative out. You have options for how you want to handle that. And so this one is unchanged when we are at 0.5 or more, at a half or more. So a half is going to be our changing point. So from negative 2 to 1/2, we're going to have the opposite one, the negative one. And then from 1/2 until 6, we're going to have the regular positive one. So 2. This is how you do math in pen. You just write bigger until, all right. There, okay, great. And you integrate your work, okay. So 7 and 8 are related. I'm gonna stick to this page for a minute. This one, I don't think that's enough room. guys gave me such little room to do this problem. Oh, Mr. Canfield, you made this. All right. X squared, 6 minus x to the 4th. Okay, so the problem is, well, let me just try. Let me say u is equal to x squared. Then du is equal to 2x dx. I don't think this is going to work for me, but I'm going to try. So dx is du over 2x. Okay, so if I do that, then I can rewrite this as u times 6 minus x to the 4th times du over 2x. Oh, there's no, these like don't cancel each other out. So there might be something to do here. I don't see it, but I do see something different that I could do. So I'm gonna do that. And that is scrap everything and start over. And what if I make u is equal to 6 minus x? Then I get du is equal to negative dx. So now I can do some replacement. And I can say x squared times u to the 4th, negative du. Yeah? But I still have this x squared here. And so what we can do is we can do this double u substitution nonsense. I like to, let's see, what do I want to do? I want to add the x and then subtract the u. That's how my P brain is going to handle that. 6 minus u squared times u to the 4th du. The reason this is advantageous is because now 6 minus u squared is easy. 6 times 6 is 36. 6 times u. Am I still on the screen? I am. Okay, I slouched. Minus 6u minus 6u plus u squared. So this is 36 minus 12u plus u squared times u to the 4th du. And then I can just distribute that John and get negative 36u to the 4th minus 12u to the 5th plus u to the 6th du. Baby integral time. We have a negative out front of everything. So 36 over 5 u to the 5th minus, hey, we're dividing by 6 here. That actually is nice. And then this one goes back to being yucky. So you can put the plus c in the it doesn't matter. I'm just going to distribute it. All right, so negative 36 over 5, and u was 6 minus x. Am I on screen? I am. Okay. Minus 2, 6 minus x to the 6th. Nope, that's a plus because I'm distributing this negative. Minus 6 minus x to the 7th over 7 plus c. Nice, simple. Everyone's happy. Not even hard. Who thinks calculus is challenging? No, legitimately though, let's say this. The hard part here is recognition of algebraic tricks that we can do. The calculus here was not bad. The calculus was, well, I can do some calculus to do a clever substitution. And then algebra. And then calculus here is, the calculus is simple. It's just, I mean, the numbers are annoying, but it's not, the actual calculus part of it is not the hard part. All right, let's do ones where the calculus is the hard part. All right, we got 2 more. This half-an-hour video is almost done. No, I'm happy I got the main content done in a half hour. So the real way this works, when we're taking the derivative of an integral, so we actually drop both bounds in. Like the real, like in super slow motion, what's happening is we're getting the integral of 4 plus 6 but what's the derivative of 4? 0. Minus 2x squared plus 6, but what's the derivative of 2x squared? 4x. So this dies, and we're left with negative 4x, 2x squared plus 6. So that is really what's happening here with these. I'm not quizzing on that next time, but that is what's happening. So here, what we could do, well, if we want to find f prime of 1, I'm going to find f prime first. And f prime is, I drop the x's in, so I get 2x to the 4th plus 1, and I'll multiply that one by 4x cubed. And then minus 2x squared plus 1 times 2x. So using that principle of we're plugging these in with chain rule. And then I'll just plug in -1 and you get who cares. So 2 times -1 to the 4th plus 1 times 4 times -1 to the 3 minus 2 times -1 squared plus 1, 2. All right, you are allowed to leave this as your final answer. If it's a free response question, you are. So you'd circle it and walk away. I'm gonna do it because I'm gonna assume it's a multiple choice question where they would give you the simplified answer. But if it's a free response question, this is actually the smartest answer to give because you don't make any silly mistakes. So now let me make some silly mistakes. All right, so that's gonna be +1, so that's gonna be 2 plus 1, negative, so -4, +1, so that's 3, that's -2. Okay, so I get 3 times -4, what, -12, -6 plus, okay, so I get -6. So when I did this, I got -6, but I am more confident that this is correct than I am that this is correct because baby arithmetic problems plague me to this day. Okay, I think that's it. Let's see, just double checking. Did that. Cool, yeah, all right. Well, I hope you're well. I hope this was helpful. And again, reach out if you need anything. Bye.